Practice Set 10, Problem 3. Compute the volume of this cylinder. When we're dealing with this type of three-dimensional object, we can find the volume by taking the area of the face times the height of the object. What we're looking for with a face is a geometric figure that has the same size and shape directly opposite of that. And if you consider this cylinder similar to a can, at the top we would see a circle, and at the bottom we would see the same size and shape directly opposite. So our face of this object will be a circle. The area of a circle is found by taking pi times the diameter squared divided by 4, and then to calculate the volume we have to multiply that area by the height. Plugging in values then for this particular problem, we'll use the approximate value of 3.14 for pi. The diameter is given as 2.6. That has to be squared. The height, the distance between those two similar sized and shaped faces, is 1.9, and divide the result by 4. Order of operations, the top priority in our values here is the squaring of 2.6. 2.6 times 2.6 is 6.76. Next, we'll simplify further by multiplying the three values in the numerator, giving us a 40.33016. And the last step is to divide by 4. We get a value of 10.08254. The instructions tell us to round to the nearest tenth. The 8 in the hundredths is enough to bump up our tenths position, so we would report a 10.1. Units for this problem, let's look back at the formula that we just simplified. Pi and 4 don't have any units, but our diameter was in feet. It got squared, so we had feet squared, and then we times it by the height, another feet. Feet times feet times feet is going to give us cubic feet, which we can symbolize with feet to the third power. Problem number 4 asks us to compute the volume of this shape. The area of the face side is 38 square inches. Well, if we go back to that volume formula that we just got done working on problem 3, to calculate volume, we take the area of the face and times it by the height of the object. In this particular problem, because they're giving us the area of the face, the assumption is that there is an equal size and shape directly opposite of that. They've calculated this irregular shape for us and given us the value, 38 inches squared, that we will times by the distance between those two same size shaped faces of 8.5 inches. Multiplying the values gives us the value of 323 inches squared times another inch is going to give us inch to the third power, which is the unit we would be expecting working with a volume problem. Problem number 5, compute the volume of this shape. In the last two examples, our face in the figure were at the top and the bottom. And if we try that technique here, you'll see that the top, which would be a rectangle, is not the same size as the rectangle at the bottom. So we need to come up with a different approach, and the approach here would be, consider the front, which is a trapezoid, would have an equal size and shape directly opposite in the back trapezoid as well. Here's that trapezoid in the front having a top value of 13, and that top value we'll call a base. The sides that are parallel we call bases. So we would have one base 13 and another 20, and the distance between the two bases, which is given as 8 in the diagram, we call height. So we're now ready to calculate the volume by taking the area of the face times the height of the object. And here, height might not be quite accurate description given our face is front and back. Instead of height, we might substitute in a value or a word like thickness or depth of this object. It's not going to alter our formula by any means, but just in terms of a descriptor, much better word to use. So, our face is the trapezoid. The formula for the area is the sum of the bases times the distance between the two divided by 2 times the height or thickness of the object. Plugging in the values for this problem, we have 13 plus 20 for the bases. The distance between the two is 8. We're timesing that by the thickness of this three-dimensional object, which is 11, and then dividing by 2 to give us that area of the face. Following order of operations, we'll simplify inside the parentheses first. 13 plus 20 is 33. We will times that by 8 and the 11. Next, and divide by 2, giving us a result of 1,452. And unit analysis here, we would have had millimeters plus millimeters, would still leave us at millimeters, but timesing it by the distance between the two parallel bases gives us another millimeter, and the thickness would give us the third millimeter. So we end up with millimeters cubed, or written as millimeters to the third power.